at some more complicated examples of how we can use what we know about special right triangles to find the lengths of some of these sides here. So look at number 29 here. We've got two triangles stuck together, basically. One of them, this one up here, is a 30, 60, 90 triangle. The other one over here is going to be a 45, 45, 90 triangle. So I can use what I know. I'm given this short leg of the 30, 60, 90 triangle. I'm trying to find the hypotenuse of the 45, 45, 90 triangle. So what I need to do is figure out what this length is here. I can use the 5 to figure out what this length is here, this leg, and then I can use that to figure out what the hypotenuse is. So that's going to be my strategy. Well, if this is 5, 5 is the short leg of the 30, 60, 90 triangle. This side that I'm looking for here is the hypotenuse of that 30, 60, 90 triangle. So it's going to be twice as long as the short leg. So it will be 10. Okay. Now, 10 is also the leg of this 45, 45, 90 triangle. 10 is the leg, then the hypotenuse is going to be 10 times the square root of 2. So I use both. Remember, sometimes they're going to be hypotenuse, sometimes they're going to be long legs, sometimes they're going to be short leg. It depends. It can change depending on where they are in that particular triangle. Let's look at another example, number 30. Again, I've got a 30, 60, 90 triangle here, and a 45, 45, 90 triangle next to it, adjacent to it. So, I'm given what? I'm given one leg of this 45, 45, 90 triangle. I'm going to use that to find the hypotenuse of that triangle, because that hypotenuse will also be the long leg of this 30, 60, 90 triangle. So 10 is the leg of the 45, 45, 90 triangle. So the hypotenuse is going to be 10 times the square root of 2. Right? 10 times the square root of 2. I just take the leg, multiply by the square root of 2. Now I have the long leg of a 30, 60, 90 triangle. Well, the short leg is just going to be that long leg divided by the square root of 3. Remember, to go from the short leg to the long leg, we multiply by the square root of 3. So to go backwards, we'll divide by the square root of 3. So x is going to be the long leg, 10 times the square root of 2, divided by the square root of 3. And we'll probably rationalize that by multiplying by root 3 over root 3. That gives us 10 root 6 over 3, and we can probably just leave it like that. Okay. Look at another one. How about this one, 32? Here, got again 45, 45, 90 triangle. This is awfully small. 45, 45, 90. So this one is 45. And this one is a 30, 60, 90 triangle. I am given the hypotenuse of the 30, 60, 90 triangle. Well, if I know the hypotenuse, I can find this side over here. Once I've got one side, I can find any other side. This is 6. This is the short leg, right? It's opposite 30 degrees of the 30, 60, 90 triangle. So it's going to be half the length of the hypotenuse. So the hypotenuse is 6. Short leg is 3. Now that 3, if we look over here, is also the hypotenuse of the 45, 45, 90 triangle. I want to find x, but x is a leg of the 45, 45, 90 triangle. To go from the hypotenuse to the leg, I'm going to divide by the square root of 2. So to find the hypotenuse, I multiply by the square root of 2. To go backwards, I'll divide by the square root of 2. So x is going to equal 3 hypotenuse divided by the square root of 2. And again, rationalize the denominator. I get x equals 3 times the square root of 2 over 2. And that's my answer. Now let's look at a couple more of those. These multi-step ones can be tricky, but you just kind of work your way around from what you don't know, from what you know to what you don't. So if I look at number 1 here, I've got a 45, 45, 90 triangle, and I have the hypotenuse. Okay, I can use that to find the leg. Right? It's going to be, to go from the hypotenuse to the leg, I'll just divide by the square root of 2. So the leg of this 45, 45, 90 triangle will be 10 over the square root of 2. I'll rationalize it at the end because I think it'll just be easier. Now this is the hypotenuse of this smaller triangle right here. The thing I'm looking for, x, is the leg of that triangle. So to go from the hypotenuse to the leg of that triangle, I will divide by the square root of 2. So x is going to be 10 times the square root of 2 divided by the square root of 2. Instead of writing divided by the square root of 2, I'll just write times 1 over the square root of 2. That's the same thing. Look what happens. 10 times 1, 10. Root 2 times root 2 gives me 2. And I didn't even have to worry about rationalizing the denominator. In general, I would wait till the end to rationalize the denominator because sometimes you lose that radical in the denominator. So x in this case is going to be 5. Let's look at number 4 over here. Again, two 45, 45, 90 triangles together. I've got the hypotenuse of the longer one, and I'm trying to find the leg of the smaller one. Well, first I'll go from the hypotenuse of the larger one to the leg of the larger one. And I'm going to do that by dividing the hypotenuse by the square root of 2. Gives me 9 divided by the square root of 2. Okay, now this is the hypotenuse of this smaller triangle. To go from the hypotenuse to the leg here, I will just again divide by the square root of 2. So I'll take, say, x is going to be the hypotenuse, 9 times the square root of 2, divided by the square root of 2, or times 1 over the square root of 2. When I do that, I get 9 from the numerator, and square root of 2 times square root of 2 is 2. So 9 halves, or 1/5 if you like. Last example, I'm going to do two 45, 45, 90 triangles. Again, I'm given the hypotenuse, and I'm trying to find the leg of one of those triangles. Well, I've got my hypotenuse is 5 root 2. First thing I'm going to do is find the leg of that larger triangle. Okay. To do that, I divide by the square root of 2. Now, obviously, those two square root of 2s are going to cancel out, and I end up with 5. So this leg of the larger triangle is 5. That leg is also the hypotenuse of the smaller triangle. Now to go from that hypotenuse to x, do the same thing. Divide by the square root of 2. X will be 5 over the square root of 2. And now I'll rationalize the denominator because I'm at the end of the problem. I end up with 5, 2 over 2. I'll just leave it